Okay, so for this circuit, we have to find the Thevenin equivalent. So the answer is already given, but let's actually see how you find them. So let's start by finding RTH. We can turn off this source, but we can't turn off this current source because this is a dependent current source, and you can't just turn them off. So what we're going to do is we're going to put a test charge and call it 1 volt. Now, RTH will be equal to 1 over the current passing through it. So let's call the current passing through it IO. The 1 over IO is going to be what RTH will be. So let's do a node. Let's call this VA and let's call this VB. So let's have a current passing through this direction. Let's call this I. Actually, let's not do this. Let's not do this. I just realized it may not work. Actually, let's do a mesh instead. Let's call this mesh I1, I2, and I3. So mesh I1, it'll be 4 times I1 minus I2 plus plus 1, yeah, okay. Now for these two meshes, we should combine them as a super mesh because right now we have to the 6 volt source is not actually here, okay. Remember, we turned that off, but that would make this I3 mesh a little weird to do because we would have 5 I3 equals 0, and that means I3 is 0, but that can't be the case. So, and we see that this source is between two reference nodes. So we're going to first write an equation. It's going to be 1.5 Ix is equal to I2 minus I3. Okay, now we're going to ignore this portion and do a super mesh. So mesh I2 and I3. So it'll be 5 I3 plus 3 I2 plus 4 I2 minus I1. Okay, and let's find a way to get rid of this Ix. We see I2 moves in the same direction as Ix, so I2 is pretty much Ix. So we can replace that with this. Alright, now we have enough information to solve our circuit. So let's distribute everything in. Alright, and then now let's work with this one. So let's bring this one to the other side. So it'll be 0.5 I2 equals minus I3. So divide both sides by 0.5, and we have minus 2 I2 equals minus 2 I3. So now for here, let's replace that. So 5 I3 plus 7 minus 2 I3 minus 4 I1. So 5 I3 minus 14 I3 minus 4 I1. So 5 minus 14, it's minus 9 I3. Let's bring the 4 to the other side, so it'll be 4 I1. And it'll be 9 over 4 I3 is equal to I1. Now for our last one, we can finally solve everything. So 9 over 4 I3 minus 4 times minus 2 I3 plus 1. This and this cancels out, so it's minus 3 I3 plus 8 I3 plus 1. Minus 9 plus 8, that's minus 1 I3, or just minus I3, plus 1 equals 0. So we see I3 has to be equal to 1. So that means I2 will be equal to minus 2, and I will be equal to minus 9 over 4. Okay? Now we see I1 is in the opposite direction of IO. So IO is equal to minus I1. So it'll be minus 9 over 4. This and this cancels out. So IO is 9 over 4. Now we can plug that into here. Hold on. Okay. 9 over 4. And that gives you 0.444 ohms. Okay, that's your Thevenin resistance. Now let's find the second value, VTH. Whoa, oops. Hold on. Sorry, give me a sec. Hold on, I'm the wrong one. Hold on. Again, sorry. What is going on with my laptop today? There we go. Alright, now let me erase all of this. Now let's find VTH. So it'll be the point at this region. So to find VTH, let's see what we can do. We can do a node equation. So let's have a current passing in this direction. Let's call it, actually let's start with here. Let's call this node I1. This one is, let's call it IX. And this one, let's call it I2. And this node, let's call it VA. So for node VTH, IX is leaving. So IX is entering VTH, and this will be equal to I1, which is leaving. And there's no current passing through here because it's an open wire. So IX will be VA minus VTH all over 3, and this will be equal to VTH minus 0 all over 4. Now for node VA, it's I2 plus IX. They're both leaving, and this is equal to 1.5 IX. So I2, let's bring this to the other side. So 1.5 IX minus IX, that's 0.5 IX. So I2 is VA minus 6 all over 5, and this will be equal to 0.5 times VA minus VTH all over 3. Okay, and 0.5, that's just 1 over 2, and 2 times 3, that's just 6. Okay, now we have enough to solve, so let's isolate for VA first. So VA over 5 minus 6 over 5 equals VA over 6 minus VTH over 6. So let's bring this to the other side, and let's bring this to the other side. So VA over 5 minus VA over 6 is equal to 6 over 5 minus VTH over 6. Okay, so let's combine these two. 1 over 5 minus 1 over 6, so that's 0.03333 VA is equal to 6 over 5 minus VTH over 6. So let's isolate for VA. 6 over 5 divided by 0.0333, that's 36, minus 1 over 6 divided by 0.0333, that gives you minus 5 VTH. Now we can plug in VA into this equation. So let's first break it up. VA over 3 minus VTH over 3 equals VTH over 4. Bring this to the other side. So it'll be 1 over 4 plus 1 over 3. So it'll be VA over 3 equals 0.5833 VTH. Times both sides by 3. So it'll be 1.75 VTH. Now VA will be 36 minus 5 VTH. equals 1.75 VTH. Bring that to the other side. So it will be 36 equals 1.75 plus 5. So it will be 6.75 VTH. Divide both sides by 6.75. And you get 5.333 to be the Thevenin voltage. And now let's write the Thevenin circuit. So it will be the voltage 5.333 volts, resistance 0.444, and then since the original circuit didn't show a closed wire here, well, we have to leave it as an open wire. Alright, so that's your Thevenin circuit.